Hi everyone, welcome to the Chem Help ASAP Wednesday live stream. I hope everyone is doing well today. So this week's live stream, we are going to be talking about how to do conversions and dimensional analysis. So what we're going to do is we are going to be converting from one unit to another. And we'll start, of course, with simple conversions like grams to kilograms or feet to inches, and then we'll move into more complex conversions. And we're also going to deal with how do you convert, say, square inches to square feet, and how do you deal with density, where usually you have two units in the numerator and the denominator, and you've got a unit that is cubed. So that is for a little bit later in the session. We're going to start with the simple ones, and then we're going to move into the more complex ones. So this is a live stream where if you want to work along with me, definitely have your calculator. Okay, so let's go ahead and get started. Okay, so first I just want to show you our conversion factors that we are going to work with. Obviously, there are many more conversion factors. You can find these in a textbook, you can find these online, but these are the ones that we are going to work with in these problems. So what I've got here is I've got what a lot of people call the metric system, or it's the SI system, where you're going to have a prefix that's going to tell you how far you are from the base unit. So for example, kilo, there are 1,000 grams in a kilogram. Or if you're using milli, it's the same thing but reverse. They're going to be 1,000 milligrams in 1 gram. So the prefix is going to tell you what power of 10 you need to multiply by. Okay, so here also down here in the lower right, these are our conversions between the SI, or again, people think of it as the metric system, between the SI system and the imperial system. Again, I'm going to stick with just these conversions right here. These are the most common ones, but there are plenty more out there that you can find. Now, because we're going to be using these conversion factors, I'm just taking this slide and you're going to see it repeated before each one, because we're going to have to reference back to what our conversion factors are and how we use them. So there's going to be a little bit of a back and forth here. Okay, so these are our conversion factors. Let's jump into our actual problems here. Okay, so again, these are our simple conversions. So let's get ready to write. And we've got 1.57 kilometers or kilometers to meters. It doesn't matter how you say it. So what you can see with these first ones is, like, if we start in the SI system, we're going to stay in the SI system. If we start in imperial, we are going to end in imperial. Again, just keep it really simple to start with. Okay, so I always write down what I am given, and I'm going to abbreviate kilometers just with a km. So when I'm writing, I'm actually going to be abbreviating, but the problems, the units are written out. Now, I like to use what I call the fence post method for doing these conversions, where I set up the problem like this. You can also you can multiply, use parentheses and multiply each factor. Whichever way makes the most sense to you, that's how you want to use it. Okay, so my conversion factor is going to go right here. I'm going from kilometers to meters, so I need to know either how many meters in 1 kilometer or how many kilometers in 1 meter. And you can use either one. Now, when I'm doing this conversion factor, I tend to think of 1,000 meters in 1 kilometer. And so let's go back and just see. You can see I've got kilo here, and it means 1,000. So that's where this 1,000 is coming from. Now, what's important in these is you want to make sure that the unit you're converting out of is going to cancel. So I need to make sure that my kilometers goes in the denominator of my conversion factor. And because I'm going to meters, that is going to go in my numerator. What happens a lot of time, especially if you start getting a little bit frustrated, or you just don't want to write down all the units, you'll start flipping conversion factors. And instead of, say, multiplying by 1,000, you end up dividing by 1,000 or vice versa. And then you end up with the wrong answer at the end. So I know it can be time consuming and you don't want to, but make sure you always write those units in, because trust me, it's a lot more frustrating to end up with the wrong answer. Okay, so I am going to do this conversion. I'm going to say there are 1,000 meters in 1 kilometer. Again, you could say that there are 0.001 kilometers in 1 meter. It is the same thing. It just depends on what way makes the most sense to you. And as I do these problems, I'm going to try and shift up how I do, especially these prefix conversions. Okay, so you can see here, all I'm doing is I am multiplying by 1,000. But of course, my kilometers cancels. I'm left with meters, which is what I wanted to do for this conversion. So this is, so that's 1, 2, oops, I put my thing in the wrong place here. So you can either write this as 1,057 meters, or you can always do scientific notation, which would be 1.57 times 10 to the third meters. Now, in all of these problems, we will be double checking our significant figures, because I know that's another thing that gets wrapped into these conversions or this dimensional analysis. So remember that this conversion factor is a definition. It has an infinite number of sig figs. So the only thing that limits me is this 1.57 kilometers. In all of these problems, we're doing multiplication division, which means we're looking at total number of sig figs, and we're deciding which factor has the fewest number of sig figs is going to determine how many sig figs our answer has. So we have 1.57 here that has 3 sig figs. Our answer should have 3 sig figs, and both of these do have 3 sig figs. So that is our complete answer here. Let's go on to the next one. So now we're going feet to inches, 0.45 feet. Again, I want to do my fence posts, and I like to put my units in first to make sure I do the math correctly. So I want feet to cancel. I am going to inches, and of course there are 12 inches in 1 foot. My feet are going to cancel, and I have converted into inches. This is another example of an exact conversion factor. So there are an infinite number of significant figures in this 12 feet to 1 inches. So all that's going to limit me is my 0.045. So if I put that in my calculator, I get 0.54 inches. This is 2 sig figs, which is correct because I have 2 sig figs here. So sometimes you're going to get a lot of, I say usually, you're probably going to get a lot of decimals. This one happened to work out to give me the correct number of sig figs, but always double check. Never trust your calculator to give you the correct number of sig figs, because it rarely does. Okay, so now I'm going seconds to nanoseconds. So I'm going to start with my original 5087 seconds, and I'm converting into nanoseconds. So I know my seconds want to cancel, and I want to go to nanoseconds. So this is where I'm going to go back to my table, and I'm going to see that nano here is 10 to the negative 9th. So that is going to be my conversion factor. There are 10 to the negative 9th seconds in 1 nanosecond. So the nanosecond, sometimes it's easy to get these confused in your head. Remember, the nanosecond is really, 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 really small. So you can either put 10 to the 9th nanoseconds, have a lot of nanoseconds in 1 nanosecond, or in 1 second, or have a really, really tiny amount of seconds in 1 nanosecond. Again, it doesn't matter math-wise. What matters is which way makes the most sense to you. Okay, so this is going to be my seconds cancel. I'm left with nanoseconds, and I'm going to get 5.087 times 10 to the 6 nanoseconds. Again, the nice thing about staying in the SI system is I'm just moving the decimal here. So my sig figs ought to work out to be correct. So you can see that this, again, this is an exact conversion factor. It's not going to limit me, but here I have 4 sig figs. And here I also have 4 sig figs. So I have the correct number of sig figs for this answer. Okay, Good, no questions. Again, hopefully you find these very easy and it's just later when we start to combine concepts. Okay, so now we're going grams to kilograms. So I'm going to write my original number, grams, that is a 5. Again, putting my units in first. I want to convert out of grams and I want to go to kilograms. Again, kilo, let me come back here, meaning 1,000. So there are 1,000 grams in 1 kilogram. Again, this can help to think, okay, kilogram is big, so there are a lot of grams in a kilogram. And that gives me 156 kilograms. Or you could put it in scientific notation. Whoops, that didn't really write. Times 10 to the second kilograms. That is a 2 there. Again, checking sig figs. This is exact. It has an infinite number. This has 3 sig figs, also 3 sig figs, also 3 sig figs. So we're good here. Again, if you're just switching in the SI system, usually the significant figures work out pretty easy. Okay, now we're doing another one, microliters to liters. This will be our last easy one. Let's see, that's going to be microliters to liters. So I know I want microliters to cancel, and I'm going to go to liters here, but let's go back and check my conversion. You can see micro here. This is the symbol that I am using just in case you're wondering. And this is a 10 to the negative 6. So it's really, really, really small. But you know, I'll do this one a little bit differently. So in 1 liter, there are 10 to the 6 microliters. Again, do this however it makes the most sense to you. My microliters are going to cancel. I'm left with liters. And this gives me 0.002005 liters. Or if you want to go to scientific notation, 0.005 times 10 to the negative third. Sorry, that 5 went a little wonky. Liters. Again, sig figs. So I have 4 sig figs here. Remember, these are captive zeros, so they are significant. So I should have 4 sig figs in my answer. And yes, I have 4 sig figs here. Remember, these leading zeros are not significant. And of course, scientific notation is great because it pulls out all those zeros that aren't significant. And you can see I also have 4 sig figs. Okay, so that's it for our easy conversions. Again, I'm putting another slide in here for conversion factors because we're going to continue to need them. Now what we're going to do is we're going to move between the SI system and the imperial system. So these are going to, again, we're getting just a little bit more complex. So here we want to convert from liters to quarts. So let's put down our original number of liters and let's get our units in. Okay, so I'm going to go liters to quarts. All right, so I need a conversion factor. So I'm going for this table right here, and here we go. Here is my conversion factor right here. That'll take me between liters and quarts. I already have my units in, and it's 1 liter to 1.0567 quarts. Now, this conversion factor is not an exact conversion factor. And when you're using conversion factors that are not exact, there's something you want to be really careful about. Your conversion factor should never limit your significant figures. If you find that you're doing a calculation and your conversion factor is limiting your significant figures, you need to look up a conversion factor with more sig figs. So when you're doing a conversion, you should never be losing significant figures. Okay, so if I put this into my calculator, again, my liters are going to cancel. I'm getting quarts. That's what I want. I'm going to get, this is where we start to get really long decimals. And I'm not even putting down all of the decimals that I get. All right, so let's do sig figs. I have 4 sig figs in my starting number, and I have 1, 2, 3, 4, 5 sig figs in my conversion factor. That's good. That means the number I started with, my number of liters, is going to limit my sig figs, and specifically, it's going to limit me to 4 sig figs. So I need 3.701 1 quarts as my final answer. Okay, let's keep going. Now we're going miles to kilometers. We've got a lot of miles. This is miles. Again, I'm going to put my units in, and then I'm going to look at my conversion factor. So I want miles in the denominator, and I want kilometers in the numerator. Let's go back and find our conversion factor. Okay, here we go. Here is our miles to kilometers. So this is the one we're going to use. So that is 1 kilometer and 0.6214 miles. All right, so I'm just going to write down here what the calculator gives me. Let's give a couple more. And let's determine sig figs. Okay, so this initial number of miles has 3 sig figs. Remember that trailing 0 there is not significant because while it is to the right of a significant digit, it is not to the right of the decimal point. So it is not significant. So I only have 3 sig figs in these miles. My conversion factor has 4 sig figs. Again, good. It's not limiting me. So I need to have 3 sig figs in this answer. So I need to round to the tens place. Again, that gives me 3 sig figs. Or, again, you can always do scientific notation times 10 to the 3rd kilometers. Again, let me just write this in. So remember, those miles canceled out, and we are left with kilometers. I really like using scientific notation where I can for these sig figs. I just find it makes it a lot easier. Okay, on to our next one. 15 pounds, and we want to convert to kilograms. So again, starting with our 15 pounds, let's get our units in. We want pounds to cancel, and we want to go to kilograms. Oh, I think I said kilometers first time. Anyway, we want to go to kilograms. Weight to weight, right? Or mass to mass. So here we go. Here's my kilograms to pounds right there. So that is the conversion factor I'm going to use. So it's 1 kilogram to 2.2046 pounds. So if I put that in my calculator, I'm going to just give out a bunch of decimal places here. Now let's determine sig figs. My starting number has 2 sig figs. My conversion factor is 1, 2, 3, 4, 5 sig figs. Okay, so definitely my conversion factor is not limiting me. That's great. I'm limited by 2 sig figs, so I'm going to round. This is going to be 6.8 kilograms. Again, my pounds have canceled, and I'm left with kilograms. Okay, great. Just want to make sure there are no questions about this. Again, hopefully you're finding these conversions fairly simple and fairly easy. Okay, meters to yards, and we're starting with 80.0. Again, let's get units in first. So meters, I want to cancel, and I want to go to yards. Let's get a conversion factor. Here we go. Meters and yards right here. Okay, so for every 1 meter, we have 1.0936 yards. Let's check, or let's first just write down all of our decimals, and then we'll check for sig figs. 488. Okay, so this 80.0 has 3 sig figs. So the thing that makes it different from this previous problem here where this 0 was not significant is you've got this 0 that is to the right of a significant digit, it's to the right of that 8, and it's to the right of the decimal point. So this 0 is significant, which makes this 0 in the ones place a captive 0, which means it is also significant. So this 80.0 has 3 sig figs. And let's take a look at our conversion factor. We have 1, 2, 3, 4, 5 sig figs. Again, conversion factor is not limiting us, so we need 3 sig figs, which means I'm going to round right here. So this is 87.5 yards for our answer with the correct number of sig figs. Okay, on to our last kind of simple one here. We're going to throw in a little bit of scientific notation. Grams, and we are going to go to ounces. So I want my grams to cancel, and I'm going to ounces here. Let's find our conversion factor. Here we go. Grams and ounces. So let's put that in. For every 1 gram, we have 0.0353 ounces. And we've got, well, let's just write down what our answer is. Okay. 590. Now let's do sig figs. Okay, so this, again, scientific notation is great. Remember, all zeros are significant in scientific notation. These, I have 3 sig figs here because those 2 zeros are significant. My conversion factor also has 3 sig figs, so that's okay. Ideally, I would like my conversion factor to at least have 1 more sig fig than what I'm starting with, but it's fine if you have the same as long as your conversion factor is not limiting you. So what we need here is we need 3 sig figs. So I'm going to have to round to that hundreds place. So I can go 10,600 ounces, or 1.06 times 10 to the, that would be 1, 2, 3, 4 times 10 to the 4th ounces. Again, either one is fine. Either one has 3 sig figs. I kind of prefer the scientific notation. Okay, good. No questions. Let's just keep on trucking here. Again, I just duplicated my conversion factor slide, so we've got it ready to go because we are going to need it for these. All right, so now we're going to be working with conversions that are going to take more than 1 step. So the previous ones, we needed a conversion factor, but we just found that factor and we used it. For these conversions, we're going to have to think a little bit about how we're going to get from our starting point to our ending point because it's going to take more than 1 conversion. Okay, so 5.5 miles to meters. So let's just put this in miles. And all I know right now is I want miles to cancel. So that's what I'm going to put in. Let's go back to our conversion factor. All right, so if I am looking here at what I can use, I've got several links, but I can go from miles to kilometers right here. That's not a problem. And then, of course, once I'm in kilometers, it's pretty easy to go to meters because that's just a factor of 1,000, again, kilo being here. So that is going to be my route. Now, when you're doing these problems, especially if you're working in a group, you might find that somebody else is going to take a slightly different route, and that is totally fine. As long as you get to the same place in the end, it really doesn't matter. Okay, so I'm going from miles to kilometers first, and then for my second conversion, I'm going to go from kilometers to meters. So you can see how my units are going to cancel, but let's get numbers in. Again, I'm pulling these from the table. So in 1 kilometer, there are 0.6214 miles, and then of course there are 1,000 meters in 1 kilometer. Now this one just happened to work out that kilometer was 1 in both cases, but it doesn't matter. That's nothing special. What you really want to see is that the miles cancel, then the kilometers cancel, and you're left with meters at the end. That is what is most important. Okay, so putting this in my calculator, just throwing out all of the decimal places. Let's talk about sig figs. Again, in these, you can see because this is a 2-step, we've got this conversion factor, which is exact, so that's fine. But we also have this conversion factor here, which is not exact. So as you string these along, you're going to have to look at each conversion factor and determine the number of sig figs. And again, it should never limit you. So if I look at my starting number, my 5.5 miles, that has 2 sig figs. This conversion factor has 4, so it doesn't limit me. And of course, my exact conversion factor is never going to limit me. So I need 2 sig figs for my answer. And of course, my calculator gave me a lot more. So I'm going to round to that hundreds place. That is a comma. Or again, scientific notation. Ooh, sorry, I'm going to have to squeeze that a little bit. Yeah, 1, 2, 3. That's 3. Okay. So again, this is where I like to use scientific notation because it just pulls out those trailing zeros that are not significant, but either way is totally fine. Okay, now let's go grams to pounds with a little bit of scientific notation to start. Okay, so this is grams. And all I know right now is I definitely want grams to cancel. So let's take a look at my conversion factors, see what I've got to work with. Okay, so I only have pounds here, but I can go pounds to kilograms, and then again, going kilograms to grams should be easy because it's just a prefix, but still it's going to take 2 steps to get there. So I am going grams to kilograms first, and then I'm going kilograms to pounds. So now to put my numbers in. There are 1,000 grams in 1 kilogram. And in 1 kilogram, there are 2.2046 pounds. And you can see again, grams cancel, kilograms cancel. Now, the other thing I want to mention is I am purposely limiting us to these conversions that I have on my conversion page. But you can go to Google and say, what is the conversion factor between grams and pounds? And it will give you a conversion factor that you can use, and you can do this in one step. But you don't have to. So if you're like in a test situation and maybe you only have a limited number of conversion factors, you can usually get to where you need to go. You just need to use a couple more conversion factors. Google is great, though, for getting these really simple ones. Okay, so if I put this into my calculator, let me get all of the decimals. 0.002 times 10 to the negative 7th. So this is even just too small to not be in scientific notation. Now let's determine sig figs. So my starting number has 2 sig figs. Of course, this is exact, and I have 1, 2, 3, 4, 5 sig figs there, so it's great. My starting number limits me. I need 2 sig figs. So this is just going to be 1.9 times 10 to the negative 7th pounds. Okay, let's keep going. So now we've got gallons to nanoliters. So let me just write down my number of gallons. And I know I want to convert out of gallons first, but let's get a game plan on. Okay. So I can go gallons here to liters. And of course, from liters, I can go to nanoliters, which is right here. Again, this is 10 to the negative 9th. So this is going to be a 2-step process. So first, let's go gallons to liters. And then we will go liters to nanoliters. All right, so let's get our numbers in. So in 1 liter, there are 0.264172 gallons. And there are 10 to the 9th nanoliters in 1 liter. Okay, so my gallons cancel, my liters cancel, and I'm left with my nanoliters, which is exactly where I want to be. Okay, let's put this in our calculator, and we'll show all of the decimals times 10 to the 7th. Let's go with sig figs. So my starting number has 3 sig figs. Again, these leading zeros are not significant. This conversion factor has 1, 2, 3, 4, 5, 6 sig figs. Great, and this is exact, so we are limited by our starting number. We need 3 sig figs right here. So let's round this properly. Times 10 to the 7th nanoliters. Okay, great. Let's make sure there are no questions. No questions so far. Fantastic. A couple more of these before, again, we're going to move on to more complex conversion factors. So now we're going ounces to decigrams, which is not a unit you see very often, but it is a totally valid unit. All right, so all I know right now is I want to get rid of ounces, but let's get a game plan in place. Okay, so ounces to decigrams. Here's an ounce conversion, so I can go ounces to grams, and then of course deci is just a 0.1, so we can go to decigrams. So again, a 2-step conversion factor here. So we're going to go ounces to grams, And then we're going to go grams to decigrams. Okay, let's get our numbers in. So in 1 gram, there are 0.0353 ounces. And in 1 decigram, there are 0.1 grams. So my ounces cancel, my grams cancel, and I am left with my decigrams, which is exactly where I want to be. Let's put this in to our calculator. We actually get not a ton of decimal places. So let's work on our sig figs here. We have 1, 2, 3, 4 sig figs here. We have 1, 2, 3 sig figs here, and of course this is infinite number. So we have a problem. Now I'm going to continue with this problem, but this one highlights that there is a real problem here with this because I only have 3 sig figs in my conversion factor, which means my answer only has 3 sig figs, which means I have lost a significant figure from the measurement I started with. So this is a situation that you do not want to be in. Now we're not going to mess with this right now, but what you do is you would go back and you would find a conversion factor from grams to ounces that gave you more than 3 sig figs. So again, this highlights you want to make sure that your conversion factor doesn't limit you. But in this case, because we're limited here by these 3 sig figs, if we wanted to do this, I think going to scientific notation here, 1, 2, 3, is the way to go. So this is, again, a situation you don't want to be in where your conversion factor limits you. So I am actually going to just highlight this because it is a great example of a problem that you may run into and how to deal with that. Okay, on to our last one. We have 3.06 terameters to miles. 3.06 terameters to miles. Okay, so again, the first thing I know is I want to get out of terameters. So let's take a look at our conversion factors. Okay, so tera up here, you can see it's 10 to the 12. So you might be familiar with the tera prefix as in like terabytes for an external hard drive. So it's 10 to the 12. So there are a lot of meters in a terameter. Okay, so now let's talk about, let's see, we're going to kilometers, or sorry, we're going to miles. Miles. Here's miles. Okay, so actually, I think we're going to have to use, well, we could use 3, but let's use 4 conversion factors. Okay, so because we have this kilometers to miles, but we're starting with terameters. And again, this is, you can do this either way. So you can just go straight from terameters to kilometers, and that's totally fine. You can do that. That would be a 10 to the 9th conversion. But when you're first starting these, I know students have a hard time switching, not using the base unit. So what I'm going to do is I'm actually going to go from terameters to meters. I'm going to go to the base unit because that is my 10 to the 12th, takes me to the base unit. And then I'm going to go back to kilometers to finally get to miles. Again, you can do this either way. Just make sure you do it in a way that makes the most sense to you. Okay, so this is going to take me a little bit of time. So I am going to go from terameters to meters, and then I'm going to go from meters to kilometers. And that allows me to use my conversion factor, which will go from kilometers to miles. Again, you can see that these 2 conversion factors here, you can combine them into one if you want, or you can do like I'm going to do, and you're going to just go to the base unit first and then switch where you need to switch. Okay, so there are a lot of meters in 1 terameter. That's 10 to the 12th. And then, of course, there are 1,000 meters in 1 kilometer. And we have 0.6214 miles in 1 kilometer. Okay, so we can have our terameters cancel, our meters cancel, our kilometers cancel, and we're left with miles. So when you're doing these conversions, know that you can put as many conversion factors in as you want. Each of these conversion factors is a multiplication of 1. So 1 kilometer equals 1,000 meters. That's 1. So again, you can add in all these conversion factors however many you want. Again, I think the most important thing is that you convert in a way that makes sense. Because you don't want to be converting in a way that feels awkward or you feel like you're making a lot of mistakes. And again, these two conversion factors here, of course, can be combined into one, and that's totally fine. But I see often students make mistakes with how many places they need to move the decimal, or sometimes moving the decimal the wrong way. So sometimes it's better and you're less likely to make a mistake, again, if you go to that base unit first like we did here. Okay, but now we're going to make the calculator do all of the work. Actually, I think I'm going to come underneath. So putting this into my calculator, I'm going to give lots of decimal places, and let's determine sig figs. So my 3.06 has 3 sig figs. This is exact. This is exact. This one has 1, 2, 3, 4 sig figs. So again, great. I should have 3 sig figs, which means I'm going to round right there. So this is 1.90 times 10 to the 9th miles. Okay, great. No questions. I know that one can be a little bit confusing because there are kind of 2 ways to think about it. Okay, on to our next set. Again, I'm plopping in our conversion factor so we don't have to slide too much to the left or right to get to what we need to. All right, so now what we're going to deal with is we're going to deal with areas, just because then we have units that are to a power, in this case specifically units that are squared. So how do you handle converting between units that are squared? This is what we're going to deal with right here. So we're first, again, starting simple. We're just going from meters squared to kilometers squared, and I'm going to show you how this works. So we have 7.1 meters squared. And the way I like to think about this is initially just ignore the squared and just think meters to kilometers. And of course, meters is going to go, in the denominator. And there are 1,000 meters in 1 kilometer. So again, first I just think meters to kilometers, don't worry about the squared. Once I've got that in, then I'm going to bring in whatever power I need, in this case squared. So what you want to do is you're going to square this whole conversion factor. So that is going to be squared, which means your numerator and your denominator get squared, and that's how things divide out. So this becomes meters squared in the denominator and kilometers squared in the numerator. And that is how your units are going to cancel. But it means that you need to make sure you take this 1,000 and square it. So the other thing that I want to point out here is make sure you're really careful about your order of operations. So you don't want to do 7.1 divided by 1,000 and then squared, because that's the wrong order of operations. Powers come first. So what I like to do, well, actually there are 2 different ways that I like to do this. So you can either take 1,000 and square it first and then do 7.1 divided by a very large number, or you can take your 7.1 divided by, and then use your parentheses, divided by 1,000 squared, and making sure your parentheses tells the calculator, hey, square this first. Now, your calculator should do that on its own, but the parentheses just give you an extra layer of protection that, again, you're not going out of your order of operations. Okay, so putting this in our calculator, making sure we're using our order of operations, we get 7.1 times 10 to the negative 6 kilometers squared. Again, remember that numerator gets squared as well. Sig figs. Okay, so sig figs are easy for this one, right? This is an exact conversion factor, so infinite number of sig figs. So we should have 2 sig figs, which we totally do, because this, of course, gave us our unit in scientific notation, which I love. Let's go on to our next one. So we're going from feet squared to inches squared. So we're going to tackle this in the same way. We're going to start with our 4.002 feet squared. And again, initially, I'm going to take out the squared and just think of this as feet to inches. I want my feet to cancel. My inches are going to be in the numerator. And of course, there are 12 inches in 1 foot. And now I put in my power, which is squared. And again, make sure you do 12 squared first before you multiply by your 4.002. Although in this case, because you're multiplying, even if you put it in your calculator wonky, it should still work out. It's when you start dividing that I tend to see students who, again, have everything written down right and the methodology is good, but they've put it in their calculator in such a way that it's not following order of operations. Okay, so my feet squared are going to cancel, and I'm going to get inches squared. And I'll put down the crazy decimal first. Let's round to the correct number of sig figs. So I have 4 sig figs here. This is an exact. So I need to have 4 sig figs in my answer. So I'm rounding right here. So this is 576.3 inches squared. Okay. Any questions? All right, good. I know sometimes dealing with these powers can be a little bit difficult. So now we're going from yards squared to meters squared. So we're not only having to deal with our squared factor, but now we're switching from imperial to SI as well. So I'm going to start with my 8.75 yards squared. And again, initially, I'm not going to worry about the squared. I just want to go yards to meters. So let's take a look at our conversion factor. And here we go. Yards and meters right there. So that's the one I'm going to use. 1 meter, and that was 1.0936 yards. And now that I have my conversion in, now I'm going to square it. My yards squared are going to cancel, and I'm left with meters squared. And putting this in the calculator, let's write down all of these lovely decimals and then decide our sig figs. So I have 3 sig figs here, and my conversion is 1, 2, 3, 4, 5 sig figs. So that's great. I should have 3 sig figs total, so I'm going to round right there. 7.32, and that is meters squared. Okay, so let's do 2 more, and again, we're going to up the difficulty level just a little bit. Okay, so now I'm going from decimeter squared to yards squared. So you can probably already see how this is going to take 2 conversion factors. But let's just take a look here. 2 yards. Here we go. So I've got a conversion factor from yards to meters, which means I need to go first from decimeters to my base unit and then go to yards. So this is going to take 2 conversion factors. So I have my 3.11 decimeters squared. Again, I'm not going to worry about the power yet. I'm just going to worry about getting my units in. So I'm going to have decimeters to meters, and then I'm going to have meters to yards. All right, let's put some numbers in. So again, decimeters to meters, 10 decimeters in 1 meter, and our meters to yard was 1 meter in 1.0936 yards. Okay, now I need to square everything. So this conversion factor gets squared, and my second conversion factor also gets squared. So what this does is it means my decimeters squared cancels, my meter squared canceled, that's my intermediate unit, and then I'm left with yards squared. So there's a lot of squaring that goes on here. Again, be careful how you put this into your calculator. So for these multi-step ones, I know some students like to square these first and just have the larger number and then go through the conversion. Some like to use a lot of parentheses in the calculator. Again, whichever way works for you, and make sure that your calculator is doing the calculation correctly so you're getting the correct answer. Okay, so this is with all of its decimals. Let's get our sig figs. So we've got 3 sig figs, we've got infinite sig figs, and we've got 1, 2, 3, 4, 5 sig figs. So we need 3 sig figs. Let's get this rounded to 3 sig figs, which means I'm going to round right here. So 372, and this is yards squared. All right, let's do one more with area with dealing with our squared factors. So this time I'm going from miles squared to millimeters squared. So again, this is going to take multiple conversions. Let's go back to our conversion factor. So if we're starting with miles and we need to go to millimeters, then what I'm going to do is I'm going to do this miles to kilometers. And then I can go kilometers back to my base unit of meters. And then I can go meters to, what are we doing? Millimeters, I think. Yeah, which is right here, which is 10 to the third. Again, you can combine these. You don't have to go back to the base unit, but I find it helpful to go back to the base unit. All right, so this is going to be a little bit of a long one. So we're starting with our 6.02 times 10 to the negative fifth. And we've got our miles squared. So the first conversion is going from miles to kilometers. And then I'm going to go to my base unit. So I'm going to go kilometers to meters. And then I'm going to go to my final unit, my millimeters. So meters to millimeters. Okay, let's get some numbers in and then we'll deal with our squared. So this was 1 kilometer to 0.6214 miles. And then of course there are 1,000 meters in 1 kilometer. And there are 1,000 millimeters in 1 meter. So finally, what I need to do is I need to square each one of these conversion factors. So that one is squared. And that one is squared. So again, my miles squared are going to cancel. My kilometers squared are going to cancel. My meters squared are going to cancel. And I'm left with millimeters squared. So I'm going to write this down here because I'm going to need some space. Oh, sig figs. Okay, so we have 3 sig figs here. I have 1, 2, 3, 4 sig figs here. And both of these are exact. So 3 sig figs for my answer. And that is 1.56 times 10 to the 8th millimeters squared. So that one looks really ugly, but we got the right answer. So it doesn't matter how it looks as long as you're getting the right answer. Okay, so again, conversion factors at the ready. Now we're going to go to our density problems. These are going to be our most complex, and we're going to have to deal not with squared factors, but with cubic factors. And actually, first, we're going to deal with just what I call complex units. All right, so this is where we're going to have to be converting to units. So this first one, you can see I want to go from miles to hour to kilometers per hour. Now this one feels like it should be more, but it's actually less because all I need to convert is miles to kilometers. But this sets us up to start doing conversions of units in the numerator and the denominator. All right, so let's start with this one, 7.14 miles per hour. Now, one thing I like to do to help myself is I will put a 1 here in front of my hour. That's always assumed, but usually when we write our units like that, we just include the number in the numerator and we don't do 7.14 miles per 1 hour. We just say 7.14 miles per hour. That 1 is always assumed. But if you set it up in a very clear numerator and denominator, it'll help you keep track of what's going on and how things need to cancel out and be converted. Okay, so I'm going to go from miles to kilometers, which means, again, I need a conversion factor. So this one should just be 1. Yes, so here is my miles and my kilometers. So I know I want my miles to cancel, and this is going to take me to kilometers. That is a 1, and this is 0.6214. You do kind of start to memorize these conversion factors as you see them over and over. So my miles cancel, and now I have kilometers per hour, which is exactly what I wanted. I don't need to mess with the hour. I just need to make sure that I remember that it is there. All right, so putting this in my calculator, 490, and let's get the correct number of sig figs. So I have 3 sig figs here and 1, 2, 3, 4 sig figs here. So I need 3 sig figs total. So that's 11.5, and that is kilometers per hour. Or you can always write it, if you like to keep it in numerator denominator form. That's exactly the same thing. You choose whatever you like better. Okay, so now we're going to go from meters per second to miles per hour. So I need to convert my numerator and I need to convert my denominator. So this is where, again, we start adding a lot more conversion factors in. I'm going to rewrite my initial value like this. So again, I put it clearly in the numerator, clearly in the denominator, and I like to write that per 1 second so it gives me a number to start with. Okay, so you can convert either the numerator first or the denominator first. It does not matter. I tend to convert the numerator first. So what I want to do is I want to go meters to miles. So I need to go... Here is my miles, but I've got to get to kilometers first. So I'm going to string together a couple of conversion factors. So first, I'm going to go from meters to kilometers, and then I'll use this kilometers to miles, and that will take care of my numerator. So that is meters. We'll go meters to kilometers, and then I'll go kilometers to miles. I'm going to go ahead and get numbers in here. So, of course, 1,000 meters in 1 kilometer. And in 1 kilometer, there are 0.6214 miles. So you can see my meters have canceled, my kilometers have canceled, and my numerator is where I want it to be. But I still need to deal with this denominator. So I need to convert my seconds to hours. Now, again, this is just a 1-step conversion, which is nice. So there are 3,600 seconds in 1 hour. Now, you could, if you didn't know this off the top of your head, you could always convert seconds to minutes and then minutes to hours. So again, this is why if you're working these problems together, the person next to you might take a slightly different route. It's totally fine as long as you're getting to the same answer. It doesn't matter. So putting all this into, my calculator and writing down correctly what my calculator gives me. This is 6.8229. Let's get sig figs in. Okay, I've got 3 sig figs, infinite. I've got 1, 2, 3, 4 sig figs. And again, this is exact, so it's infinite. So I should have 3 sig figs in my answer. I'm going to round right here. So this is 6.82. And now I am, let's see, seconds have canceled. So now you can check. You're in miles per hour. Miles per hour. All right. So again, this is, you kind of have to get used to this. You have 2 units. You started with 2 units and you have ended with 2 units. Okay, now we're going to fuel efficiency. We've got kilometers per liter and we need to convert to miles per gallon. So again, we need to convert a numerator and we need to convert a denominator. It doesn't matter which one you convert first. Like I said, I tend to convert the numerator first, but it doesn't matter. Okay, so kilometers to miles. Well, at least this is a 1-step conversion. I know I've got that. Here it is. Here it is, kilometers to miles. So kilometers to miles, and that is 1. There we go. That is a decimal. Great. Okay, so that is canceled, and now I've got miles, and now I need to go liters to gallons. Okay, that's liters to quarts. I don't want that here. Liters to gallons right here. Now, remember when you're converting your denominator to get this liters, for that liters, sorry, I got a little tongue tied there, for that liters to cancel, you need to make sure that it goes in the numerator and then your gallons go in the denominator. This is again where it's really, really important that you write your units down and you make sure that they cancel like you want. And this is why, again, if you're not writing your units down and you're dealing with the denominator's units, very, very often students tend to flip these conversion factors the wrong way. Again, their methodology is right, but they're just not writing down their units, and so we're getting flip-flops. Okay, so numbers. That's 1 liter, and that was 0.26417. Had to kind of squeeze that in. Gallons. So you can see my liters are canceling, and I'm left with gallons, which is exactly what I wanted. So now it's just a matter of putting this into my calculator, and I'll write down all of these, and now we'll do sig figs. So I have 3 sig figs, 1, 2, 3, 4 sig figs, and 1, 2, 3, 4, 5, 6 sig figs. So that's not going to limit me. I'm limited by my start number, which is 3 sig figs. I'm going to round right there, 30.1. And now you can see I am miles per gallon. It's MI per gallon. Okay, we're almost there. Now we're going to deal with our densities with our cubic conversions here. So we're going to handle these the same way that we handled our areas where we had it squared, but the complicating factor here is that with density, again, you have 2 units. You have a numerator and a denominator, which both have units. So for these conversions, we're kind of bringing it all together here. We're converting numerator and denominator, and we're also dealing with units that have powers. That sounds funny, units that have powers. 7.86 grams per centimeter cubed. Okay, and we want to convert this to pounds per feet cubed. So we're going to have to convert grams to pounds and centimeters cubed to feet cubed. Just like usual, I tend to go with my numerator first. So if I'm going to pounds, So if I'm going to pounds, I've got my pounds to kilograms. So I'm going to first take grams to kilograms and then to pounds. All right, so we've got 1,000 grams in 1 kilogram. And then we're going to get rid of the kilogram and go to pounds, and that conversion factor is 2.2046. All right, so my grams have canceled, kilograms have canceled. So now I've converted the numerator. I've gone grams to pounds, but I'm not done yet. Now I've got to go centimeters cubed to feet cubed. So let's go back. I've got feet to meter. Well, that's fine. I can go from centimeter to meter and then meter to feet. So again, I'm going to string along a couple of conversion factors, but I like to think of this first without the cubes, and then I'll put the cubic factor in. So again, because my centimeter is in the denominator, I first want to go centimeter to meter, and then I'm going to go meter to feet. So there are 100 centimeters and 1 meter, and we just saw this conversion factor, 3.281. Now I need to cube these guys. So this one gets cubed, and this one gets cubed, so that my centimeters cubed cancels, my meters cubed canceled, and I'm left with feet cubed again in the denominator. So this one is just really long. Again, this is what happens with density. If we put this into our calculator, I'll give a couple of decimal places. Now let's convert to the correct number of sig figs. So I have 3 sig figs here. That's exact. I have 1, 2, 3, 4, 5 sig figs. That's fine. That's exact. And I have 1, 2, 3, 4 sig figs. Again, this one is exactly perfect. I need to do 3 sig figs for my answer. It means I'm rounding right there. So this is 491. And you can see we have pounds in the numerator per feet cubed in the denominator. All right, our last one, again, this is another long one because we've got to convert from ounces per inches cubed to kilograms per kilometer cubed. So I have to go ounces to kilograms in my numerator and inches cubed to kilometers cubed in my denominator. So 5.0 ounces per 1 inch cubed. All right, so now I'm first thinking ounces to kilograms. Let's go back to my conversion factor. This is to kilograms. Okay, I can go ounces to grams, and then of course I can go grams to kilograms. So that is my game plan for this one is to go from ounces to grams and then grams to kilograms. Let's get some numbers in. That was 1 gram and 0.0353 ounces. And then, of course, there are 1,000 grams in 1 kilogram. Okay, so my ounces have canceled. My grams have canceled. So my numerator is right where I want it to be. I want it to be in kilograms. Now I'm going to deal with my denominator. So I've got inches to kilometers. Inches to kilometers. I can go, let's see, I can go feet to meters. So I can go inches to feet, feet to meters, and then meters to kilometers. I'm going to string together quite a few conversion factors here. Okay, so I want my inches to feet. Then I'm going to have my feet to meters. And then finally, I'm going to have my meters to kilometers. Again, you don't have to spread it apart into these 3 different conversion factors. Google will give you the straight one from inches to kilometers if you want to do that, but I am just limiting myself by the conversion factors that I have access to. All right, so 12 inches in 1 foot, 3.281 feet in 1 meter, and then 1,000 meters in 1 kilometer. Okay, but remember, this is inches cubed. So this gets cubed. This one gets cubed. And last but not least, that conversion factor gets cubed. So now what we've got is we've got our inches cubed cancels, our feet cubed cancels, our meters cubed cancels, and we're left with kilometers cubed. Now I'm ready to put it in my calculator. Again, being careful that you make sure that the powers get done first. And now let's do sig figs. I have 2 sig figs and 5.0 ounces, 3 sig figs here, infinite, 1, 2, 3, 4 sig figs, and then infinite. So great. My 5 ounces limits me. I need 2 sig figs, so I'm going to round right there. And this is 8.6 times 10 to the 12th. Again, double checking. I have kilograms in the kilograms in the numerator and kilometers cubed in the denominator. Okay, so that is it for our conversion factors. We did a lot of converting there. And you can see usually you have pretty simple conversions, but it is important to know how to deal with those conversions that are raised to a power, and also when you have to convert a numerator and a denominator. So I hope you found this live stream helpful. Again, if you ever have any questions while I'm working these problems, please feel free to leave something in the chat. We are here to answer your questions. If you have requests for future live streams, other topics that you're covering in class that you're maybe struggling with, please let me know what you would like to see, and we can work problems of all different kinds of topics. Thanks so much for joining us. Bye.